All right, everybody, welcome to my talk, Introduction to Interloop Security, Shifting Left But Better. So quick overview today. We won't spend much time on this slide. Tell you a little bit about myself. I'm a first-time RVAsec speaker, so super excited to be here. I've been doing this work in some way, shape, or form for about 17 years now. I started off as what we would now call a full-stack developer. What that really meant was I knew Delphi and Fortran and databases and everything in between. Ultimately moved into consulting, where I've had a very exciting career. Spent some time with a little boutique firm by the name of AppSec Security that I'm super proud of, working with the founders of OWASP and a whole bunch of other people who are smarter than me. Did some time in Big Four, where I worked at EY and led our DevSecOps for financial services, so working with some of the biggest and most mature application security programs in the world and scaling them. I'm passionate about really everything I do around AppSec and DevSecOps, as will probably be obvious in this talk. I think we do it all wrong. This whole talk is based around how I think shift left itself is particularly flawed. And I'm a big believer in developer enablement and just making things easier for developers, making security the path of least resistance. And when we make security easy, it will just happen and people will do it. Really fortunate, married my high school sweetheart. I like video games, hiking, guitar. Next few weeks are particularly exciting to me. If anybody plays MMOs, we've got a big expansion for Final Fantasy XIV coming out. If you like fantasy books, we've got Wheel of Time coming out on Amazon. I couldn't possibly be any more stoked for that. So, thesis for today's talk. Shift left is an outdated sentiment, and it's no longer relevant in the world of Agile and DevSecOps. It's developed into a culture where we punish developers for taking an interest in security. And ultimately, there's got to be a better way. So the end result of this talk is really I want everybody in here to think about developers, your development teams, and the impact that we have on them as cybersecurity practitioners. So I want this to be pretty interactive, so show of hands. Let's start off easy. How many of you all are in cybersecurity? All right, pretty much everybody. Is anybody a developer? Half hand, all right. How many of you write scripts, even if you're not a developer? So quite a few people, right? Yeah, I would argue to be in security, you have to be able to do at least some level of coding. How many of you are on an AppSec team or do AppSec? All right, a handful. How many of you have an AppSec team at your company, even if you're not in AppSec yourself? Yes. All right, so got a good mix here. It'd be interesting. Normally I present this talk to developers and AppSec teams and DevSecOps conferences, so we'll see how it goes with the cybersecurity group. So I guess first of all, again, this talk is really about DevSecOps, so we need to agree on what that means before we start, because probably everyone out here thinks something different when I say DevSecOps, right? So to just boil this down, make it really simple, what I mean is performing security inside of DevOps, or doing application security at speed and at scale. So regardless of your preconceptions about DevSecOps, for the next hour, this is what DevSecOps means. So before we talk about shift left, right, we just kind of need to level set a little bit further, especially since a lot of you aren't developers. Right? We need to understand the software development lifecycle, and hopefully everybody, even in security, has at least heard of the software development lifecycle before. It's kind of like the scientific method. So it's basically the process that developers follow, the lifecycle, as they're writing code. And it goes from, and there's tons of these, right? If you Google software development lifecycle, you're going to find 100 different models. They're all variations of the same thing. They're all correct. Right? But it basically goes from requirements to design to implementation to testing to deployment and then release and maintenance. It's a very waterfall concept from back in the day when we used to write waterfall code. And if you Google it, you're going to find this written in all sorts of different ways now, right? We've written it for Agile, and it's the same damn thing. It's just inside of an infinity symbol. We've adapted it for DevSecOps, right, where we just took security and put it around the infinity symbol, and have just messed it up really badly along the way. But explaining it in a waterfall way makes it really easy to understand, because it's linear, right? And we can all take a look and we can understand what these 6 items on the screen mean. So what do we mean when we talk about shift left, right? And if any of you have ever been to any AppSec talk ever in your careers, you've probably heard about shift left, right? And every AppSec talk starts with some scary numbers and a graph, and we talk about how we find issues with pen testing, and they're really expensive to fix, and if we find and fix those issues earlier in the software development lifecycle, it's cheaper. It takes less time for us to fix them. It costs less money. And depending on whose paper you're reading, those numbers vary anywhere from 30 to 150 times more expensive to fix issues in the requirements phase than in the maintenance phase. And so this term shift left kind of came about, which referred to, all right, well, everybody in the world is basically pen testing. Even if we're not doing AppSec, we're probably pen testing our apps sometimes. Well, let's start doing things earlier, right? Let's look at static analysis tools. Let's talk about threat modeling. Hopefully some of you in this room are as excited about threat modeling as I am. With the OWASP Top 10 2021, OWASP is now saying everybody has to threat model. NIST just wrote a paper 3 weeks ago that says if you're not threat modeling today, you need to be threat modeling, and not only do you need to be doing it, you should be doing it multiple times per release for your applications. So look forward to that impacting a lot of you in the very near future. So to boil it down really simple, right? Shift left is just doing things earlier, right? And you'll hear other people talk about, shift everywhere, or in Devops we'll talk about shift right. It just means doing security throughout all of this software development lifecycle, regardless of what yours looks like. All right, and so let's talk a little bit about the history of shift left, because this is one of those things that, I've been doing this again for a long time. I've always heard shift left. Literally every vendor talks about it, every conference presentation. So I kind of asked myself, well, where did this come from? Right? What started this shift left thing? And when did it start meaning? Let's give the developers tools that are hard to use, analyzers that give them false positives, that print out 700-page PDF reports that nobody ever reads, right? Like, when did shift left come to mean this? And so when I actually traced it back, shift left actually wasn't even an AppSec concept. It was an article written in 2001 by Larry Smith. So that was the first surprise to me, right? It wasn't a pen test article. It didn't even talk about, stopping pen testing or doing testing earlier in the software development lifecycle. It was a quality assurance, a QA testing article that was talking about writing testable code and doing QA-focused testing throughout the software development lifecycle. Right? And this is a quote from Larry Smith here. Bugs are cheap when caught young. You can catch bugs earlier by making QA a part of your development, not just a part of the release process. If you go to any DevSecOps talk today, that's probably almost verbatim what a lot of these people are going to talk about. This was 20 years ago. This guy wrote this. So my question is, why isn't this our reality, right? Like, how did shift left change meaning along the way, and why did this focus on QA testing never happen? And we even got a big quote that I'm not going to read you here from Larry Smith that talks about how embracing QA testing and doing it throughout the software development lifecycle is going to make your life so much easier. It's going to make management think you're not working at all because you're working so smart and not hard. And even kind of cautions in the very last line, but don't let it look too easy. All right, Josh, so you obviously don't like shift left. Why not? Right? So security responsibilities are added to developers without any thought regarding the impact. Who here has static analysis tools in your organization? Who here has said that's a shift left activity and because it's pluggable into the IDE and has given it to the developers and forced them to use it? Okay, there was a half hand back there. We have one honest person. It's poorly implemented. It often results in punishing developers. Right? I'm also not a big fan of security champions programs, right? Because I've been in consulting for a while now, and I have seen many security champions programs fail. right? And the reason they fail, or one of the many reasons, is because they all start with this nomination program, right? Because we say, okay, well, we have like one, to your point over there, of these AppSec unicorns in our organization. We've got like 12,000 apps. How on earth do we possibly scale this program? Oh, great, we have these AppSec champions, right? So we find some poor developers who, maybe mentioned OWASP, or they found a bug in one of the apps, and we say, they would make great champions. You know what we should do? We should give them more work, make them use tools that aren't designed for developers. We should not pay them anymore. We should not give them a cool title, and then expect them to do all of these things that our security team is well trained to do. And then we wonder why our AppSec champions programs fail, right? That right there is why they fail. Tools aren't designed for developers. Off the top of my head, I can't think of a single application security tool out there that is designed, they may be marketed towards, but they're not designed to be used by developers. Almost all of them take significant work to configure them, to get good results, to tune them, to go through the results, to do what we call a triage, to get rid of the false positives. Almost all of them are prone to false negatives. They take up time, right? Especially a lot of the old IDE plugins. You give them to the developers and they click scan, and they're single-threaded even, so their IDEs lock up for hours at a time. Then they can't do their job, which is writing code. Our developer performance reviews don't include security, right? So we want our developers to be an arm of our AppSec program, but then we don't grade them on it, right? At the end of the day, developers' jobs are to write code, and right, to push out business features and business functionality. And then we want them to do it securely, but that doesn't reflect in their performance reviews. So how on earth can we expect them to do things securely if we're not going to grade them on it? And then finally, the value provided by shift left, in my opinion, is questionable. I should have asked before we started, does anybody here work for a tool vendor? Hopefully not. Last week I presented this, and one of the guys worked for Now Secure, and it was a little, felt a little bit bad. All right. So, all right, that's a lot of complaining and talking about the problem, right? But we need to come with solutions, not problems. So how do I think we can do this better? So come up with what I call the inner loop. And I say I come up with it, but I really didn't. I actually originally discovered this through a client of mine. And they had found this really cool article from a developer at Microsoft by the name of Mitch Denny. And his link is up here on the screen. If you try to go there, it won't work. The site is now down, but if you use the Internet Wayback Machine, you can go and view the blog article that kind of drove this whole presentation. But it's nothing new, right? Interloop has been around for a long time. It's been used for automotive manufacturing, software development at Microsoft, project planning, a whole bunch of other places. The only thing innovative I've done is adapt it for AppSec. So what is the interloop? So this will probably be kind of exciting for the developers in the room, maybe a little bit boring for everyone else, so we'll see how this goes. But the interloop, you can kind of think about it, right? If you think about the developer software development lifecycle, the inner loop is everything from the time the developers put their fingers on the keyboard until they push a commit to a local Git or whatever repository. Nowadays, it's typically Git. Everything that occurs after the local Git commit is considered the outer loop. So really, it's the developer's local development lifecycle. Anything we would think of as CI/CD or kind of traditional DevOps is going to fit into what we call the outer loop. So to kind of put a really ugly graphic behind this, we kind of have these pre-loop steps over here to the left, right? Because there's some things that are going to be out of scope for this conversation: secure design patterns, threat modeling, architecture reviews, training, all of those things that are happening outside of development, right, that we would traditionally consider shift-left activities, are kind of out of scope for this model, right, because at this point we've already started developing. But then the actual inner loop itself consists typically of 4 activities: coding, building, testing, and committing. You can see them there in the circle on the left. Then here in the middle, we've got a pull request. to take our code and push it to a Git repository, right? At that point, that's where we transition from the inner loop to the outer loop. And then that right circle is just going, a little more detailed, right? Because modern day, again, it's not waterfall anymore. We've got a lot of developers writing code, pushing out features, making commits, right? So within the outer loop, it's really a whole lot of different inner loops happening all at the same time that are pushing to that same outer loop, right? Because it's, again, where you don't have single developers working on a single project anymore. It's a whole lot of people committing to that code base. And so if we kind of think of a DevOps reference architecture here, you've probably seen similar drawings before. Again, there's nothing super innovative here, right? This is just kind of a typical, security implementation or AppSec implementation within the DevOps world, right? If we start up there at the top left, hopefully we're doing this, right? Creating user stories, epics, sprints, tasks, right? All of our planning in Jira, which hopefully security is involved in many of your organizations, probably not. Then we have threat modeling and architecture reviews. Then we go into coding. Right? We write all of our code, we do our sprints, whatever. We take our code and we push it out to source control. Right? This is where we get into the outer loop. So at this point, we're no longer in the inner loop. And the reason I stress that is because in a lot of these other talks or your vendors and everything that you hear about today, security is plugged in further down the list here, right? Because if we keep kind of following the arrows, we go to the build system, right? This is our Jenkins, our Azure DevOps, whatever we might be using, right? It builds our code, pulls in our libraries, all that good stuff. Well, then at that point, we have these CI/CD pipelines. And that's where we take and we plug in all of our tools. We plug in our static analysis, our dynamic analysis, our IAST if we're super cool, QA testing, code quality, all of that stuff, right? And we throw all of this into our pipeline, and then a whole bunch of other stuff happens, right? So, point here is, all of that today is happening in the outer loop, not the inner loop, right? And all of that is impactful to your developer's build process. All right, so a couple other key concepts that we need to understand that's critical to this model is really tax and waste, right? So let's start with the key tenets of the inner loop. Loop execution should be as fast as possible. So if we start thinking about traditional AppSec tooling, our tools aren't fast, right? Anybody who has run any of these tools before, you take a static analysis tool, you run it, you wait somewhere between 5 minutes to 2 hours, maybe longer, you get results. If you run a dynamic analysis tool, maybe you've waited for days to get results. The tools are not fast, and they're typically not accurate. Feedback time should be minimized, but quality should be optimized, right? So again, things should be fast, and they should have quality results. Tax should be minimized, and waste should be eliminated. All right, so what's tax and waste, right? Some of you are probably already reading the slide and know what they are. But if we break down these activities in the inner loop, right, the coding, building, testing, committing, right, only one of these activities provides business value. That's coding, right? We're taking features, we're taking customer demand, we're converting it into code, and we're putting it into our application. That is the only one of these activities that actually benefits the business. Building and testing are necessary activities that we have to perform as developers, right? We could write code all day long, but if we never compile it, it never does anything, right? And our compiler throws us some errors, tells us our code is broken, maybe there's just some warnings, or if we're really lucky, maybe it actually compiles, and then we can run our app and see what it does. But the point is, building and testing are necessary activities that we have to do, and they provide us feedback, right? They tell us if our code runs, maybe sometimes even tells us if we have vulnerabilities, right? But it gives us feedback about that code that we wrote. And then we have committing over there, which is really an essential evil. It's an activity that we still have to perform, but it's not providing us feedback in any way, right? It's not looping back into this coding process in any way. It just lets us get our code from point A to point B. So that kind of brings us to these concepts of tax and waste, right? So tax are the necessary activities that we have to do that we're not going to get around, and they take time, but they provide feedback. Right? And waste is just like tax, except it's unnecessary. So, kind of key to this inner loop model is reducing tax and eliminating waste. And then we got this big blurb down here, right? Conventional AppSec tooling introduces large amounts of tax and waste. So just like the real world, right? We don't want to pay taxes. We have to do it, but it's a necessary evil, right? And again, a lot of us nowadays are, fairly conscious. We want to do good for the world, right? We know plastic is evil, and we don't want to use plastic bottles or plastic straws, right? So we want to get rid of all that waste. So this is where I'm going to need some participation from everybody, because I'm going to kind of walk through some thought exercises here and just talk about some different types of common application security tooling, and just kind of think about the tax and waste, and if we think these different types of tools will work in this inner loop model based on everything we just introduced. So static analysis, right? So, static analysis tools, this is referring, for those of you who might not be in AppSec, kind of a category of tools that scan our source code, right? And then they go through. Some of them require the source code to compile, some don't, but point is it scans the source code, and then it says, hey, we found these vulnerabilities. Some of them were lying to you, and it's really not vulnerabilities, but we think it is within the source code, and so you need to go out and fix these because it might be SQL injection or whatever it might be. So check marks, AppScan source, Fortify, shift left, are a handful of the tools that kind of qualify as static analysis. So for those of you who may be well versed in these tools, what do you think about static analysis? Do you think static analysis is a good inner loop tool, and why?
There could be some value of something quick that is local for something like SemGraph or something to start off getting some sort of inference or know that something could be dangerous.
Mm-hmm.
Or to just start and be able to quickly nullify that process. And if that could happen soon enough, maybe that would be something they could place attention to.
All right. Any other thoughts on static analysis? Good.
I would also say yes, with the caveat that developers have had education around how to identify vulnerabilities and also tools that you configure for your environment.
Okay. Anyone else? Good, back there.
I have a more philosophical response. The tools that we have today, we understand there's limitations because they're acting our evolutionary process.
Mm-hmm.
So if we look today and look retrospectively at the internet, when you're not getting 16,000 photos, we probably could have a talk just like we're giving that was critical about the value, right?
Mm-hmm.
It flat out sucked, right, in those days. It's had the ability to evolve and improve, and some of that was software-based, and some of that was connectivity, right, plumbing with that connection. So I think static analysis tools have their value, and they will get better over time as developers start to make static analysis tools better and more in alignment with what's beneficial for them and for workflows.
Okay. All right. So I'm going to kind of half agree, half disagree with all of that. I think part of my hesitation is, kind of to your point, right, about going back to the 56K days. It's been about 20 years since we first developed the initial static analysis tools, and we've seen very little improvement, right? AppScan Source and Fortify were kind of the two initial vendors in this space, and if we look at them today compared to where they were 20 years ago, they're about the same. They really don't do much more. I'd argue that checkmarks is probably one of the biggest innovators in this space, and they just don't require your code to compile. But otherwise it's kind of the same under the hood. To your point about SemGraph, I do see some future in tools like SemGraph. It needs to get a bloody UI on it so that people can actually use it. But at its core, it does have some potential. But if we kind of relate it back to the inner loop model, and there's no right or wrong answers to these, right? Again, this is just thought exercises. This is just my opinion. Yours may differ, and that's part of the idea here, right? But I think static analysis tools in general, they have long scan times, which all of the scan time is a tax. They all have problems with false positives, right? We have to go through. They require a triage. We've got to get rid of all those false positives, hopefully, before we give it back to the developers. So then just maybe they don't ignore us, and all those false positives are a waste. They take a lot of expertise to use, which is another tax. And then we require scan configuration as well, which is another tax on top of that. So dynamic analysis. So again, for the uninitiated, dynamic analysis, we're talking about tools like Web Inspect, AppScan Enterprise, Zap and Burp to an extent are dynamic analysis tools. But basically, this is where we're taking a scanner and we're pointing it at a running web application. We've got a tool that's kind of simulating 1,000 monkey hackers, just crawling your website, getting a good baseline, and then sending a bunch of malformed HTTP requests back to your site and seeing what happens, right? And the whole idea being if it has a baseline, if it has a good HTTP GET request and a response, right? We get a 200 back, everything looks good, and then it sends, say, a cross-site scripting payload, and it sees a 200 come back, and also that input inside of the response, it's going to say, ding, 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 vulnerability. So I guess same question, right? Dynamic analysis. What do you all think for the inner loop model? Good. Okay.
It seems like there could be more tax with less waste.
Okay.
Simply because of your ability to know or hope that the indication of the response would maybe reduce a little bit of that, what you identified as waste on previously.
All right. Anyone else? Okay. I think I'd largely agree with that, right? So dynamic analysis, again, our app has to be deployed before we can do dynamic analysis, so that's kind of a waste. DAST is, by nature, much more accurate than static analysis tends to be, right? If we get a result back in a DAST tool, it largely tends to be a real finding, so that kind of gets, a good thumbs up. Varying scan times can range from hours to days. That's kind of a huge tax there. I helped out an organization once that had DAST scans that were taking over a week for a single application, right? That's not good. And just by nature of how the tools work, the reports can be inconsistent from one scan to the next. So for those of you who have used DAST tools, this may be a frustration of yours, right? Where you'll run a scan, you'll have some, 10 SQL injection findings, and you won't change anything, and you'll run the scan again, and you'll have 5 SQL injection findings. And at that point, you lose all your developer trust because they say, well, I can't trust the tool because the results are inconsistent from run to run. But the big problem here is that your app has to be running. So even if we forgot about this whole tax and waste thing, the app's got to be deployed before we can run dynamic analysis. And I tend to have a lot of issues with the vendor messaging here too, because every vendor now talks about how DAST will plug into the CI/CD pipeline and we can automatically scan our apps, and it sounds really, really great to all the cybersecurity people. But what we don't realize is that most of us aren't at a level of DevOps maturity where our apps are automatically being deployed as a part of our CI/CD pipeline, right? We still have change management and idle and all these other things that we have to worry about. And even if we can deploy them, it's probably going to a static host, and then we're just having a static configuration around the DAST tool, right? To really do this right, we've got to be deploying to ephemeral host. We've got to be able to, dynamically set up authentication and authorization, before we can really do this in a pipeline. You have a question?
Yeah, the cool part about DAST too is typically apps will have a production QA environment, but the QA environment is constantly changing when stuff gets merged and automatically deployed and set up well. So the thing with DAST is you have to have your own separate environment for it, otherwise the application keeps constantly changing while it's running. So it's a big burden sometimes.
Absolutely. Or maybe for those of you who have run it in production, you've maybe broken an app before. So I know I have. All right. Manual pen testing, right? And that one's just there because it's funny. Right? Manual pen testing is never going to be in the inner loop, right? And it's in a perfect world, I would kind of love to get away from manual pen testing with some other things we'll talk about here in a minute. I think it still tends to be a crutch, and there's a lot of things we can do to really reduce the amount of time that we spend on pen testing. All right, software composition analysis, or open source analysis, or one of 100 other different acronyms that all kind of mean the same thing. So again, for the uninitiated, right, this is getting more into our third-party libraries and dependencies, and particularly relevant today with supply chain security. So these tools primarily are looking at your dependencies, your libraries, your third-party code that you're pulling down into your applications. And then it takes a look at all of those libraries and it goes out to the internet in some magical way, and it's looking for known vulnerabilities inside of those libraries, right? So for example, if you have jQuery 1.9.x or whatever, and it's going to see that you have that library, right? It's going to look at your POM file if you're a Java shop using Maven, maybe in your npm build, NuGet, whatever you might be using, right? And then it's going to go out, it's going to look up jQuery 1.9, and it's going to say, hey, do we have any CVEs, for this particular library? If so, the tool will report them and tell you that you have some CVEs inside of your application. And here, we're talking tools like Black Duck, Sonatype Nexus, White Source, a handful of others, even some free tools. Retire.js technically does this, OWASP dependency check. What do y'all think about software composition analysis?
The biggest problem with these tools is they are valuable in my opinion, but they don't give you any context. They'll just flag a library, it could be just one specific function that it uses, but it won't look in your application if you're using that multiple function or not. They'll just say, I see you using this version, therefore it's wrong. And so you just waste a lot of time going through that, making sure that my application uses one edge case scenario of this function that I don't use.
Which is a huge waste. Yeah.
Value. I think there's value in it, but it's just annoying.
Yep. Back there.
I think as a concept, it could be one of the most valuable and inclusive of the ones that we talked about. But we need a tool that has the most comprehensive coverage of third-party libraries, and that would operate in a way that wouldn't be
Okay. Okay. All right. So, software composition analysis, I think I kind of largely agree, right? It's good and it's bad, right? It's kind of got its pros and cons. I saw a very interesting talk from Jeff Williams, co-founder of OWASP, last week. And he was talking about software composition analysis and open source code and some of the work he's been doing. And I think at this point we've all seen enough presentations, right? We've seen the icebergs, and I think everybody talks now about how like back in my Fortran days, we wrote 80% of the code and 20% of it was open source or whatever, and how that model is flipped, right? And now 20% of our code we write and 80% of it is open source libraries and dependencies. And so what he's done with some of the instrumentation work that he's done, like with Contrast and other tools, is actually try to take a look, like you mentioned, at the code that's actually executing. And I don't remember the exact number, but what he found was that on average across all of the applications they have tested, well, it was actually something like 85% of the code that actually executes is code that you wrote. Right? So even though 80% of our code is open source and third-party dependencies, we never actually execute it, which means it's just sitting there doing nothing, really getting false positives from software composition analysis tools. So most organizations are using software composition analysis in kind of a scanning mode. Right, we throw it out in our CI/CD pipeline, and we just have it run, or maybe we even schedule it, to where it runs against our apps on build or more of an ad hoc or a scheduled basis, right? So, we all find out about something exciting like, Heartbleed or struts or something like that. We still don't have a software bill of materials or anything like that. Hopefully y'all are working on that because that's coming. And so then we have to go out and we have to scan all of our applications and figure out where that impact is, right? One of my clients had 15,000 applications in their application portfolio, right? If something like another struts issue comes along, how can you scan 15,000 applications and figure out which ones have the vulnerable version of struts, right? And you just absolutely can't. And I think that's a huge tax. To your point, it's difficult to determine the actual impact, which I would argue is a waste, right? I've built a lot of my career on helping financial service organizations that have a mature AppSec program, right? If you don't have a mature AppSec program and you put in something like software composition analysis, your developers might even love you, right? Depending. If you tell them that they have an issue, they might actually go out and fix it and swap out that library. If you have an organization that's really mature in AppSec, the developers are going to push back on that, and they're going to say, well, I'm not even calling that vulnerable code. Or show of hands, how many of you have ever read a CVE before? Most of you. Do those CVEs usually tell you how to reproduce a vulnerability? Do they tell you where in the code that vulnerability is? It's usually something fluffy, like there's a cross-site scripting vulnerability in this particular library from version X to version Y. It doesn't tell you where the vulnerable code is, and unless some super cool hacker has written an exploit or something, you probably have no idea where that is. So, a developer is not going to go out and re-architect their application because you told them there might be a vulnerability in a library. I will say, these tools are getting a lot of innovation. They're coming a long way, and I think there is ways to deploy them well in the inner loop. SNCC is a good example of this. Black Duck even has some lightweight features. So, now like Black Duck, for example, you can configure it so that if, say you're writing a Java application, you go into your POM file, you add a new library, it'll pop up and it'll say, hey, did you know that library you're trying to add right now has a vulnerability? Maybe you want to use this version instead. Right, and so basically zero impact to the developers. We can go ahead and let them know and let them make the decision of whether or not to proceed. SNCC is doing some really cool stuff also, right? So if you can configure SNCC in such a way as part of your pipeline even, so that if you're trying to deploy an application, it's going through your CI/CD process and it finds a vulnerable library, SNCC will actually break the build and it will actually create a pull request to go out and take a newer version of that library and incorporate it into the code base for you. Now you're all in cybersecurity, so that probably scares the shit out of you, which is fine, right? It's understandable, but it's what your developers need to do anyway, right? And what you're going to tell them to do if you had been the ones to find this vulnerability. So as long as you have a good, pull request approval process in place, that can be incredibly valuable. So I want to talk a little bit about security as code. This is almost a separate, actually really could be a separate talk in and of itself, right? And I think it requires a little bit of an introduction before we kind of talk about it as a thought exercise. So kind of before we talk about security as code, because this is kind of a prerequisite here, I want to talk about testing vulnerabilities versus testing controls, right? So today, most of us test for vulnerabilities, right? This is how all of our tools work. It's how our pen testers work, right? And security, right? This tends to be what we hunt for, right? We find vulnerabilities. But from an AppSec perspective, this causes a lot of problems. For one, we get really, really good at finding vulnerabilities. Or for some of us that have used some of these tools we've talked about, right? I've run static analysis tools that after you're done running them, you have 60, 70, 80,000 vulnerabilities from one scan of one application, right? For those of you, hopefully all of you, with mature vulnerability management programs, right? How do you manage 80,000 vulnerabilities, across your network, even where we're really good at vulnerability management, right? We would probably fail with that many vulnerabilities. And that's just in a single app from a single scan, right? And the more we do this, the better we get at tuning our tools, we get better at pen testing, and we really just find more and more vulnerabilities. Some of those are false positives, false negatives. We don't treat vulnerabilities as defects, right? We're still giving developers, PDF reports and things like that. We expect them to read them. We don't treat vulnerabilities as defects. And really what we've started is a race that we can absolutely never win. And so what I think we need to do is change our focus from vulnerabilities to controls. Right? And again, this is something else we've gotten fairly good at, with our networks, our hosts, right? A lot of our security teams nowadays, we're thinking about, security controls, mitigating controls, et cetera, right? But we're not doing it from an AppSec perspective. So, it's just important to know from an AppSec perspective, thinking about controls and testing for the presence of controls as opposed to vulnerabilities, right? It enables us to do some really cool stuff, like have security design patterns, right? I think the very first slide, I talked about making security easy, right? We don't do that well today. We run a scanner or we get a pen test. The pen tester comes back and says, hey, we found this cross-site request forgery vulnerability and you need to fix it. And the developer says, okay, cool. What the hell is a cross-site request forgery? The security person, probably says, I don't know. Here's what the pen tester said. Go read their report and fix it. Right? So, but if we give them a design pattern, that tells them how to prevent cross-site scripting and the code to put into their application that stops it from to begin with, most developers are going to write their code with that design library already in there, right? And this enables us to eliminate entire categories of vulnerabilities, right? So again, if we're hunting vulnerabilities, if we do a pen test, a static analysis scan, whatever, say it finds 10 SQL injection vulnerabilities. Well, that's just what it found, right? There could be 20 or 30 or maybe even more, right? So if we're focused on the vulnerabilities, we're only going to find and fix some of the vulnerabilities within our code, but there's always going to be more, right? But by focusing on those controls and implementing strong controls, we could eliminate those entire categories. Getting back to this inner loop thing, that also lets us do this stuff fast and accurate, right? Have any of you ever run a QA test before? Right. It's fast, right? You run a QA test, it's what, maybe milliseconds, right? So if we can write a QA test that will test for a security control and have a result in milliseconds or seconds that's accurate and tells us if that control is there, that's incredibly valuable, right? And so now that's what we're talking about with security as code, right? So we have to agree on a control first. Once we have the control, we can write the requirements, which we can turn to QA test. And I always use the example of having just a conversation with a CISO, right? Because this is something that happened to me once, right? A CISO came to me and said, hey, can you promise me that my application does not have any cross-site scripting vulnerabilities in it? No, right? If anybody in this room can say yes, you're probably a liar, right? We can never guarantee, right, that we don't have a vulnerability in our app. We might be able to say, oh, hey, we've had 10 pen tests and we found 2 and we fixed them, or checkmark said that we don't have any. But can we really say with confidence that there's none there? We absolutely can't. However, if we all agree as a group that something like OWASP SAPI will prevent cross-site scripting in our applications, and here is the snippet on how to incorporate that into our apps, well, now we can write a QA test for that. It's going to run in milliseconds and check our application and tell us if that control is present and configured properly. And so now if the CISO comes back to me and says, hey, Josh, can you guarantee me my app doesn't have cross-site scripting in it? I still can't say yes, but I can at least say, hey, we've agreed on this control that prevents this vulnerability, and here is all of the green lights and the test results saying that this was done properly, right? So at least according to the thing that you agreed to, yes, your application is protected from cross-site scripting. So that was a long tangent, but that's what we mean by security as code. And I'm running a little low on time, so we're going to skip the thought exercise here a little bit. Short version is, personally, I think security as code is going to save the day, right? This is kind of part of the key to enabling developers and being able to do AppSec at agile speeds, right? And we can do security as code both in the inner loop and the outer loop. And actually, we kind of have to use it in both because some things like unit and functional QA testing, we can do within the inner loop, but things like integration testing and end-to-end testing, we've got to have all of the libraries. We've maybe even have to have the app running. So just by the nature of those types of tests, the application does have to be in the outer loop. But when done properly, security as code, in my opinion, has immeasurable amounts of tax and waste. And it also reduces what we have to do with all those other technologies, right? If we agree on OWASP SAPI, if we agree that it prevents cross-site scripting, well, I don't really need to test for that anymore, right? I can configure my static analysis tools, my dynamic analysis tools, that if this QA test passed, well, I don't really need to run those on every build anymore, right? So I can start tuning those scanners so that they're less impactful when they are running that pipeline. All right, security spell checkers. Sorry, security, cybersecurity people in the room. This is one of those things that I think to cyber people sounds fantastic on paper, right? And we get really excited about this. Hey, how great would it be if this developer was writing a vulnerability and we stopped them in the middle of it and told them they were doing it wrong? It probably sounds really, really great, right? But it's really not. And in 100% of cases I've seen where these tools are used, they've been actively fought or disabled by the developers, right? And this really gets down to, just lost time, right? There's a lot of studies out there that show that every time you're focused on a task, such as writing code, and you're taken out of the moment, you're distracted, you read an email, you check your phone, whatever, you lose 23 minutes of concentration, right? It takes you 23 minutes to focus back on that task. So every time you interrupt the developer from doing their job and writing code, you're taking 23 minutes of time out of their day that they could be writing those business features. So again, right, to security, it sounds fantastic, but to developers, it's an absolute nightmare. I will say, in my opinion, this is an area where we could see a lot of innovation in the next couple of years. Right, we've had some cool new things come out like GitHub Copilot, that kind of writes code for us. It's still a little iffy and does some weird stuff, but it has potential to be able to do this and write code for us. Not only write code, write secure code. Right, think of Gmail. I can open up Gmail now and type in hi and then tab, and Gmail will write my email for me with pretty much the words that I would use. Right, that's awesome. If we get these security tools to the level of maturity where they can do that, they could be incredibly valuable in the inner loop. All right, so wrapping up, model for the future. So this is I was in Big Four for 4 years, so I've got to have a slide with as many buzzwords in it as I can. Performing security inside the inner loop drives a shift-left culture that shortens developer feedback loops to release code at high velocity by leveraging secure by design principles. And then we've got, again, in typical Big Four fashion, just a few slides here with a whole lot of words that I'll publish and you can read at your leisure. But, really the key message here is, right, I would encourage all of you, the inner loop and the outer loop work together. I'm not saying stop doing things the way you're doing them today. I mean, I kind of am, but, the CI/CD pipelines are still great. Automation is great, right? Don't automate things for the sake of automating them. Think about the impact. But the inner loop and the outer loop, they work together. They're hand in hand, and they allow us to change how we're doing things today so that we're enabling our developers, rather than punishing them, right? Our outer loop is not scalable, right? Every time we put another tool in our pipeline, it takes more time, right? And right now, your development teams are severely outpacing you. Right? They're trying to release code. Maybe it used to take them 8, 9, 12 months to release an app. Now they're releasing them in 4 weeks, 2 weeks, If you're Amazon, Netflix, maybe 8 seconds, right? And if we take a tool that takes 8 hours to run and we put it in our pipeline, well, you just created an 8-hour bottleneck. So I'm getting the sign here to STFU. So we're just going to jump to the conclusion here. So in conclusion, right, I want you to use the inner loop, again, as a thought exercise, just like we did, to consider the impact that you're having on development teams. So instead of making these decisions, purchasing tools, giving them to developers, and then wondering why they hate you, just consider that impact that you're having, right? There is no right amount of tax and waste. It's going to be different for every organization, right? So figure out what works for you, have the thought exercises, and adjust accordingly. Right? Continuous improvement now also changes, right? It becomes more of continuously reducing tax and waste. You're going to have a lot of tax and waste today, and that's okay. Think about how you can reduce that. And then don't shift left simply for the sake of shifting left, right? We're doing this a lot. Just like don't automate for the sake of automate, right? If you take a 24-hour process and you automate it, it's still a 24-hour process. You just don't have to push the button anymore, right? We got to figure out how to make that process more effective as well. Same thing with shifting left. And then we're out of time, but if you have any questions, feel free to find me. Happy to talk about this more.